Hello everyone, myself is Joshita from Triply Department. Today my topic is about potentiometric sensors and amperometric sensors with example. Potentiometric sensor and amperometric sensor. Concepts: sensors, potentiometric sensor, working principle, applications of potentiometric sensor, amperometric sensor, working process, application of amperometric sensor, example, advantages. Sensors. Sensor is a device used to detect the change in physical or chemical quantity and produce an electrical signal to the computer. There are three types of sensors. They are potentiometric sensors, amperometric sensors, and conductometric sensors. Let us see one by one. Potentiometric sensor. Potentiometric sensor is a type of electrochemical sensor that used to measure potential difference of an electrode. Potentiometric consists of two types of sensors. Working principle of potentiometric sensor. Potentiometric sensors are used to measure the concentration of ions in a solution. These sensors typically consist of two electrodes, a reference electrode and a sensing electrode. The sensing electrode is coated with a membrane that selectively binds to a specific ion in the solution. When the ion binds to the membrane, it creates a potential difference between the sensing and reference electrodes. This potential difference can be measured and used to determine the concentration or activity of the ion in the solution. To facilitate this measurement, a potentiometer is used to measure the voltage difference between the two electrodes. The potentiometer is connected to a display device such as a meter or computer which displays the voltage reading. By using known calibration standards, the voltage reading can be converted to a concentration or activity value for the ion being monitored. Ions that can be monitored using potentiometric sensors include potassium, calcium, and pH. Applications of potentiometric sensors. Gas sensors are useful for the detection of toxic gases, ion selective sensors, water quality measurements, biomedical applications, blood gas sensors, industrial applications, glass electrode for detection of H plus ions present in the test solution. D-glucose plus H2 gives rise to gluconic acid plus H2O2. Amperometric sensors. Amperometric sensors are the type of electrochemical sensors that measure the current produced by redox solutions. These sensors are commonly used for the detecting and quantifying specific analytes such as glucose, hydrogen peroxide, and cholesterol in biological and environmental samples. Amperometric sensors are the types of electrochemical sensors that measure the current produced by redox reactions. Working principle of amperometric sensors. Through redox chemical reactions, amperometric sensors generate current. This current is detected by working electrode. This produces an electrical signal. Through redox chemical reactions, amperometric sensors generate current. This produces an electrical signal. Applications of amperometric sensors. Environmental monitoring, medical diagnostics, food and beverage industry, biosensors, blood glucose monitoring. Environmental monitoring. Amperometric sensors can be used to detect and monitor pollutants like gases, heavy metals, etc. Medical diagnostics. Amperometric sensors can be used to monitor the level of glucose, cholesterol. Food and beverage industry. They are used to detect and measure the concentration of enzymes, vitamins, and other nutrients. Biosensors. Amperometric sensors are used to create biosensors that detect the presence of specific biological molecules such as bacteria, proteins, and DNA. Blood glucose monitoring. Amperometric sensors are commonly used in glucose meters which are used by people with diabetes. Example, uric acid plus O2 plus H2O gives rise to, in the presence of uric acid, allanitinium and CO2 plus H2O2. 2H2O2 plus 4APP plus TOOS gives rise to, in the presence of peroxidase H2O plus chromogenic acid product. The amount of current flow is equal to the amount of uric acid. Advantages: oldest method known, accurate determination, high sensitivity of a device. Thank you.